Dear students, welcome to the video Geometric Progression. Geometric progression is a sequence or progression in which the ratio between any two consecutive terms is a constant number, This constant number is called common ratio, denoted by lowercase r. Let's look at this example. For example, you have this geometric sequence 2, 6, 18, 54, and so on and so forth. As you notice here, the ratio between 6 to 2, which is 3, is the same as the other two consecutive terms, 18 to 6, is equal to 54 to 18. They all have the same ratio, which is equal to 3. This constant number 3 is called common ratio, denoted by r. R is 3. And as you already know from the previous part of this chapter, A is the common, let me add it here, the first term of the progression is denoted, as you know we had for arithmetic sequence or progression, is denoted by lowercase a. So in this case, A is 2. Now, let's make a formula representing terms of geometric progressions. Now, if the first, let A be the first term, and R be the common ratio. So the first term, let's write first term, second term, third term, fourth term, and I'm going to find a general formula for the nth term of these such a progression. Now, the first term, as you know, is denoted by A. As you see, common ratio is 3. Common ratio shows that this number is multiplied by this r, which is 3, to obtain the following term. For example, 2 is multiplied by 3 to obtain 6. 6 is multiplied by 3 to obtain 18. 18 is multiplied by 3 to find 54. In order to find the fifth term of this progression, 3 should be multiplied by 54 is multiplied by 3, which gives you an answer of 162. So the next term of this progression will be 162. Now, likewise, we are going to implement this point here. So, in order to find the second term of this progression, so first term is multiplied by the common ratio, which is r. So the second term will be AR. The third term, so the previous term of the third term, which is second term, is AR. So one more time is multiplied by r, so it will give you ar squared. Then the fourth term will be, again, if you multiply ar squared by r one more time, it will be ar cubed. As you see here, in the second, actually the first term, the power of r is 0 because there is no r here, if you see, because r to the power of 0 is 1. In the second term, the power of r is 1. In the third term is 2. In the fourth, 3. Likewise, 5 will be 4. So to make a general formula for the nth term, it will be a r to the power of n minus 1. As you see here, the power is 1 less than the position of the term. So we can make a conclusion here. Nth term of a geometric progression will obtain by the formula a r to the power of n minus 1. Now let me put it in the box. One is here. So the answer will be a r n minus 1. Example 1. The fifth term of a geometric progression is 1 and the common ratio is half. Find the eighth term and an expression for the nth term. So it, as you see, the fifth term, which is a r to the power of 4, is equal to 1. So fifth term is replaced by 1. A is unknown and common ratio is half to the power of 4. So a will be 16. If you expand, it would be 1 over 16, then do cross multiplication, it will give you 16 as the first term. And you have the first term, you have the common ratio. In order to find an expression for the nth term, an is a r to the power of n minus 1. In this case, a is 16 times r, which is 1 over 2 to the power of n minus 1. You can simplify. 16 is 2 to the power of 4 times 1 to the power of n minus 1 will be 1. Then 2 to the power of n minus 1. And you see, when you have two indices, in order to divide them, powers are subtracted. So overall, it will be 2 to the power of 4 minus n minus 1. Then there is no need to write 1. So an will be 2 to the power of 4 minus 1 will be 5, then negative, and it is an expression for the nth term of this progression. Example 2. The second and fifth terms of a geometric progression are 12 and 40.5 respectively. Find the first term and the common ratio, hence write down an expression for the nth term. Now, it says the second term is actually 12 and the fifth term, so a5, is 40.5. Now we know that second term, which is 12, is actually a r to the power of n minus 1. N is 2 here, so it will be 1. So there is no need to write. And 40.5, which is the fifth term, is a r to the power of 5 minus 1, which is 4. I labeled this formula 1, the second one 2. Now, here I divide the formula 2 by the formula 1. So it will be AR4 over AR is equal to 40.5 over 12. If you remember, for arithmetic sequence, in order to find when you have two given terms and first term and the common difference are unknown, you make simultaneous equations to solve. Here, as it is a matter of multiplication and division, this technique can easily be implemented in order to find A and R. As you see here, when you divide these two formulas by each other, A and A cancel out each other, then you will have one unknown that can be easily found. R cubed over R will be R to the power of 3 is equal to 40.5, 12. They are all divisible. If you simplify them, it will be 27 over 4 actually. Sorry, 8. Now, in order to get rid of power 3, I take a cube root from both sides. It will be R is equal to third root of 27 is 3, third root of 8 is 2. It is the common ratio. So we found the common ratio. You can replace here in order to find A. So 12 is equal to A times 3 over 2. So A will be 12 multiplied by 2 divided by 3, which will give you an answer of 8. So you have the first term, you have the common ratio. It's easy to write down an expression for the nth term. Nth term is a r to the power of n minus 1. N is equal to a, which is 8. R is 3 over 2 to the power of n minus 1. Then if you simplify, it is 2 to the power of 3, 3 to the power of n minus 1, 2 to the power of n minus 1. Now an will be equal to, you have the same base, you can subtract powers. It will be 2 to the power of 3 minus n plus 1, which will be 4 minus n, 3 to the power of n minus 1. It is an expression for the nth term of this progression. Now in this part we are going to learn how to find sum of n terms of a geometric progression, which is denoted by Sn. Now, so we know that Sn, which is sum of the first n terms, is equal to actually the sum of the first term plus second term, which is AR, plus third term, AR squared, then AR cubed, till the last term, which is AR to the power of n minus 1. Now, as we already know, R is a non-zero number, so I'm allowed to multiply both sides of an equation by a non-zero number. So I multiply both sides by R, so it will be Sn multiplied by R, which is equal to AR plus AR squared plus AR cubed plus AR4 plus the last one, which is let me write the one before the last one, which is AR n minus 1 plus AR to the power of n, because the term before this term was AR to the power of n minus 2. When it is multiplied by 1, so powers are added, it will become to the power of n minus 1. Now I'm gonna subtract these two equations from each other. So on the left hand side we will have Sn minus Rsn is equal to, but on the right hand side, if you subtract, you have A, because there is no similar like term in the second expression equation to cancel out a, so it remains, but AR minus AR cancel out. These two cancel out each other. These two cancel out each other, and likewise here. Then these two terms. So what we have left, it is A minus AR to the power of n. So here I factor Sn first. Sn 1 minus r is equal to, they have common factor of a, 1 minus r to the power of n. Now I divide both sides by 1 minus r because we are looking for Sn. So Sn will be equal to a 1 minus r to the power of n over 1 minus r. So it is, the formula can be used in order to find the sum of n terms in a geometric progression. Let's see some examples. Now, example number 1. Find the sum of the first 12 terms of the geometric series 3 plus 6 plus 12 plus 24. As you see here, the first term is 3 and the common ratio is 2. All, frequently are multiplied by 2. 3 times 2, 6 times 2, 12 times 2. So in order to find the sum of 12 terms, we use this formula a 1 minus r to the power of 12 over 1 minus r. So S12 will be equal to a, which is 3 times 1 minus 2 to the power of 12 over 1 minus 2. Now S12 will be equal to 12,285 as the final answer. Second example, the third term of a geometric progression is 9 times of the first term. The sum of the first 6 terms is k times the sum of the first 2 terms. Find the value of k. As you see, A3 is 9 times of the first term. So it will be 9a. We know that a3 is a r squared is equal to 9a. Cancelling out a from both sides, r squared will be 9, giving you an answer of positive negative 3 as common ratio r. Now, using the second statement given in the question, says the sum of the first 6 terms, so S6, is k times the sum of the first 2 terms, so S2. So S6 will be A1 minus r to the power of 6 over 1 minus r is equal to k A1 minus r squared over 1 minus r. I can cancel out a from both sides, 1 minus r as well from both sides, so k will be equal to 1 minus r to the power of 6 over 1 minus r squared. Now, once I consider r positive 3, once I consider negative 3. Now, if r is positive 3, then k will be 91 if you replace. In this case as well, again k will be 91 as well. So overall k will be 91 in both cases.